Hi, for our ME220 project, we are doing the push-up buddy, and for this idea, we are placing the Pocket Lab sensor on the chest of the user, and we are going to be measuring the elevation change off of the ground during a push-up, as well as the stability of the midsection. We're doing this by using the IR rangefinder for elevation and the accelerometer to measure stability in the X direction. The user will wear a strap around themselves that will hold it in place to avoid tilt, which could disrupt the IR sensor. And we are incorporating sensor fusion in this because not only do you want to go down far enough on a push-up for it to be a valid push-up, but you also want to have good stability in your back so you have good form.
Once the sensor is affixed to the subject, they can begin using the app for Push-Up Buddy by clicking on a button to do a baseline push-up, doing the baseline push-up itself, and then tapping that when they're done. After they do the baseline push-up, the readings for the baseline push-up showing the depth to which they do their push-up as well as the acceleration in the X direction can be seen, and then they have the option to begin their workout. We say that a push-up has good depth if the user is able to get to within 80% of the depth that they were able to get during their baseline push-up. We also say that the push-up is done and completed when they get back up to within 20% of their initial starting position. The same logic is applied for the stability of the push-up. If the acceleration during the push-up is within 110% of the highest value during the baseline, then we say that the push-up is stable. A good push-up is registered when both the depth and the stability of the push-up is adequate.
The operating range for the rangefinder is between 0 meters and 1 meters because we don't expect anyone's arms to be longer than 1 meter. The resolution of the rangefinder of the Pocket Lab is 1 centimeter. We anticipate the longest signal to be the slowest push-up, which we estimate to be 5 seconds, and the shortest signal to be 25 Hz, which is half of the sampling rate due to the Nyquist theorem. That would correspond to a frequency range of 0.2 Hz to 25 Hz, or a bandwidth of 24.8 Hz. The operating range for the accelerometer is between -1G and 1G, which was determined from the unstable push-up example that we did. The range for that push-up was roughly -0.2 Gs to 0.2 Gs. We want a factor of safety of 5, which corresponds to -1G to +1G. The resolution of the accelerometer in the Pocket Lab is 0.008 Gs. We anticipate the longest signal to be the slowest shake from side to side, which would take roughly 1 second, and the shortest signal to be 25 Hz, which is half of the sampling rate due to the Nyquist theorem. That would correspond to a frequency range of 1 Hz to 25 Hz, or a bandwidth of 24 Hz.